We chose to target with Spitzer a particular type of star called a white dwarf that it represents the fate of virtually all the stars in the Milky Way, including our sun, which will eventually become a white dwarf. And these stars have such high gravity that they essentially have pure atmospheres, which are composed of only lightest elements like hydrogen and helium. However, a significant fraction of them have metals in them, like calcium, which is also seen in our sun, which basically shouldn't be there. And so we know that these elements have to be external pollutants. They have to be put there from the outside. One way to do this is to pick up material from an interstellar cloud, but none of these metal-polluted white dwarfs are located near clouds. Another way to do it is pollution from a remnants of a planetary system which has survived to the current epoch. And so the Spitzer observations have confirmed that roughly 20% of the targets that we looked at have rocky debris that is very closely orbiting and is consistent with something like an asteroid which has been thrown into the inner part of the system and torn apart by the star's gravity in the same way that the Saturn's rings were created. We think this debris is rocky because of the composition that we see, the pollution pattern of chemicals in the white dwarf, and because of the infrared radiation that it gives off. And so it stands to reason that if there are leftover kind of building blocks, rocks, that once were analogous to, say, asteroids in our own solar system, then they probably had rocky planets and may still have rocky planets today.
So these are the sort of ancient solar systems that perhaps once were planets but have now...
Yeah, probably the innermost planets probably got swallowed or destroyed, but simulations of our own solar system show that although the Earth may not survive, Mars and the asteroid belt probably would survive to the white dwarf stage. And so we could be seeing something like the fate of our solar system. A bit uncertain and perhaps a bit bleak if the debris that we're seeing was once an Earth-like planet, but there's still the possibility that there are a few intact planets around. In fact, we need something probably more like a Jupiter to throw the rocks around so one comes close enough to the white dwarf and gets broken up and gets turned into the dust that we see in the infrared.
So is there any chance of being able to detect ingredients that may once have made up an Earth-like planet that perhaps may have been habitable?
In fact, I think that's what we're doing. Right now, we've only taken my collaborators actually, have only taken a really close look at a few stars, but that work is in progress right now. And the one star that's a really spectacular example, they've detected 17 heavy elements in this atmosphere, and if they compare the pattern of those elements with the Earth and the Moon and Mars, you get the best match with a combination of the Earth and the Moon. And so it does look like, in fact, that we are seeing the leftovers of Earth-like planets.
And how many systems did you study?
Well, we looked at a bit over 50 stars with Spitzer, and we've discovered 14 that have these dust disks that look like they're broken up asteroids. There's a few more coming in the next months as we publish more of them.